to record our class here so that if you ever want to go back and rewatch part of it, or if you miss a part and you want to go back and see what we went over, you will be able to. All right, let's see here. Where are we at? There's where we are at. All right. So like I said, this is from my last class. We don't need to be worried about it here. All right, so like I said, on Tuesday, we were going over our states of matter, the different phase changes that they can go through, how matter heats up and the different temperatures it takes on that heating curve. Today, we're going to talk about some of the different chemical and physical properties and changes that matter can be described with or can be put through. All righty here. So when it comes to describing matter, which again is just our fancy science way of saying stuff that's out there in the universe, we can describe the physical aspects of matter and we can describe the chemical aspects of matter. We can describe the different properties that matter can have, and we can describe the different ways that matter can change from being or looking like one thing into another. So today we're going to go through each one of these different types of descriptions one by one and talk about what they are and some good examples to kind of explain the different types of descriptions and characteristics that we can give to matter. So we'll start off by talking about matter's physical properties. So a physical property of matter is something that we can describe about matter, a characteristic of it that can be observed. So something that we can measure or see or even hear or smell or taste. Because remember, if you remember back to our first week of class, we went through the scientific method and I talked about making observations. I mentioned that you can make observations with all 5 of your senses. Yep, Maylee, I'm recording this right now. And so the video of this will go on the Google Classroom, and these notes are posted on the Google Classroom right now as well. If you look under the 4-15 notes, chemical and physical properties and changes, you can find it posted in there. So observations are things that you can make with any one of your 5 senses. So usually we like to use sight to observe things, but you can also smell, touch, taste, or hear things as well. So physical properties of matters, things that we can see or measure about matter, things like the color that it is, the size and shape that it takes up. So how much space does it take up in an area? The state of matter is another example of a physical property. So whether or not it is currently a solid or a liquid or a gas, that's something that you could observe about this matter. That's something that you could use to describe it. Measurements like density. So what is its ratio of weight to size? And even just a simple measurement like mass. So you put it on a scale and the weight of the matter is one of its physical properties. So anything that you can observe, see, touch, hear, smell, or measure, things like mass, density, temperature is a good one. Hey, Guillermo, good to see you. Temperature is another example of a good physical property that matter can have. all these are ways that you can like describe matter, right? So physical properties tend to be very descriptive of the matter, a description of its physical characteristics. So again, you can observe it. By observing it, you're not changing its identity, so you're not doing some sort of like chemical testing on it and changing what it is. You're just looking at it, touching it, smelling it, maybe, I don't know. Whatever you need to do to observe the physical properties of this matter. So some really good examples of physical properties would be like if you took the temperature of this ice cube, it would be 0 degrees Celsius, because that is the freezing point of water. If you cool water down below 0 degrees Celsius, it will freeze. So that type of measurement, that freezing point, is one of water's physical properties. It's something that you can observe about water. It freezes into ice. These big chunks of metal right here, just by looking at them, you can probably tell they're going to be really hard. They're going to be probably pretty heavy. They look like they're shiny, kind of a silver gray color. They're probably, if you feel them, they're probably very smooth, but very firm and hard. So all of these are physical properties of this metal, things that you can observe about this metal just by looking at it or feeling it, picking it up and feeling it in your hand. Those are all physical properties. Similarly, our plastic water bottle over here, when you look at it, you can tell that it is see-through, right? So light, for the most part, goes right through the water bottle, and you can see the table that's on the other side. And if you picked up this water bottle, it'd be pretty easy to squish it and bend it. And if you wanted to, you can even squish it down between your hands. So the fact that it is very bendable and kind of pliable, you can move it around easily, is also a physical property, right? Metal, not going to do that. You can't bend up this metal and twist it into new shapes, right? It's pretty tough. It's pretty hard. Whereas this is a lot softer and more squishable, more malleable. And then again, just as a reminder, physical properties doesn't just have to be things that you can see or feel about an object. If you look at this piece of fruit down here, at one point in its lifetime, it probably was nice and sweet and tasted delicious. That was about a couple weeks ago, based on the state of it. At this point, if you put your nose close to it and smelled it, it would probably have that really gross, rotten fruit taste or smell. I don't know if you guys have ever smelled it. It's like that really nasty, like sticky, sweet, moldy kind of smell. Ugh, grosses me out just thinking about it. So it's going to smell really bad. And if you somehow managed to not smell it and picked it up and shoved it into your mouth, it probably tastes really bad too. So those are also descriptions. These are also things that you could observe about this fruit. So these are physical properties of this rotten fruit, is that it's very smelly and it tastes really gross. So physical properties are all about descriptions. They're all about different ways that we can describe the characteristics of these things. Either things that we can see, like the shininess or the clearness or the color, things that we can feel, like the squishiness of the water bottle or the smoothness and the hardness of metal, things that we can measure, like the temperature of the water, or even things that we can smell and taste, like fruit that has gone real bad. So all of these are physical properties, physical descriptors of our matter, of our substances. So what if we took these objects and changed them up a little bit? Like, for example, this looks like 3 different pieces of metal, but at one time it was probably one big chunk of metal. So one big piece that then got broken up into 3 smaller pieces. They're still all the same metal. They're still all the same structure, the same matter, but they used to be one big piece and now they're smaller broken pieces. So we've changed a little bit about what this matter looks like. And so when matter goes through a change like that, when it changes how it looks, but it still has the same matter, the same stuff, that is classified as a physical change. Excuse me. So a physical change is when we change the form of a substance, meaning what it looks like, but we don't change its identity, meaning that we don't change it into something new or something different. We start and we end with the same substances. They just, they maybe look a little bit different. So the properties of our substances, for the most part, remain the same, right? Sure, maybe they might be a different size or a different weight when you break them up into pieces. But like in our metal example, it's still metal. They're all still going to be hard and dense and gray and shiny and smooth on the top. So most of the physical properties remain the same. It's still metal. It's just in 3 smaller chunks instead of in one big piece. So melting is another really good example of this, right? If you took that metal and you heated it up super hot in like an industrial furnace, that metal eventually will melt into what's called molten metal, which just means a liquid version of the metal. It's still the same matter. It's still the same set of chemicals, right? It just has gone from a solid piece of metal into a liquid piece of metal that kind of looks like lava or something like that. Same thing with something as simple as an ice cube, right? If you take the frozen water that we call ice out of the freezer and put it on your countertop and leave for like an hour, when you come back, you're going to see some liquid water on your countertop. It's still water. It's still the exact same chemical as it was before, the exact same matter that it was before. It just has changed state. It's melted, and it's gone through one of those 6 phase changes that we talked about on Tuesday. And it went from solid water to liquid water. Still the same water, did not change the identity of the water. We just changed its form from solid to liquid. Same thing with if you shred something up. So like if I took my piece of notebook paper here and ripped it out of the notebook and tore it up on camera here in front of you, I'd end up with, I don't know, maybe 10 or 12 pieces of small chunks of notebook paper. They'd still all be paper, right? They'd still all have the same general properties as paper, but they would look a little bit different. Instead of being in one nice big rectangular sheet, now they're in a big pile on my keyboard. So that is what we get with a physical change. We change how something looks, but we don't change what it is. It's still the same matter. It's still the same chemicals. So some really great examples of physical changes include putting something like this big tree limb here through a wood chipper. Because on the one side, you're getting wood and putting it in. And on the other side, you're getting wood that's coming out. It's just that this wood is a big log or a big branch or something like that. And this wood has been pulverized into millions of tiny pieces that we call sawdust. But it's still the same wood, right? There's not any sort of chemical reaction inside the machine that changed it into something different. It just went from one big piece of wood to a couple million tiny pieces of wood. Still wood, but different shape means that we have a physical change on our hands. Same thing with if you boil water, right? So we talked about vaporization was one of our phase changes on Tuesday, heating something up so hot that it starts boiling and changing from a liquid to a gas. Up here, we have some water vapor, some gaseous water. Down here, we have some liquid water. This is water. This is also water. It's just changed form from one state to another. It's gone from a liquid to a gas. But because this is water and this is water, it is still a physical change. We have not changed the water into something new. We have not combined it and created some new chemical. It started as water, and it's going to end as water. We've just changed a little bit of how it looks, what it looks like to us. So that makes it a physical change. Finally, over here, I don't know if anybody else's mom did this to them when they were younger, but when me and my brother and sister were little, if we had like a sore throat or like a scratchy voice or something like that, my mom would make us gargle salt water. It was gross. I hated it. It tasted like swallowing the ocean. And I'm not even sure that it worked, but it's what she made us do. So she would put some salt into the water and swirl it around, and then it would look like the salt disappeared, right? But then when you put some into your mouth and you have to gargle it for a minute, kind of like mouthwash, you taste all the salt in there, right? It's really gross. It tastes like seawater. It's nasty stuff. And that's because the salt didn't disappear or go away. It just changed form. It went from being in big salt crystals that we could see, like the ones on this spoon and that are falling in here. And then when it hit the water, it dissolved into tiny salt crystals that are still salt. They're still in there as salt. They just changed their shape. They went from lots of salt bound up together in big crystals into little tiny pieces of salt, all moving throughout the water. And so we didn't change the salt into anything new or anything different. It just dissolved from a bigger piece to a tiny piece in the water, but it's still salt. So the salt went through a physical change. We started with salt, we ended with salt. It just looks a little bit different. We can't see it anymore when it gets mixed with the water. But we can still taste it when our mom makes us put it in our mouth and swirl it around to cure our sore throat or something like that. Same thing is the reason why you put sugar into your morning coffee, right? You wake up in the morning, you make your cup of coffee, but black coffee tastes gross. I don't know why people like to drink it. It's nasty. You got to put some sugar in there. And so you dump in your sugar and you swirl it around for a little bit, and then it feels like the sugar goes all away. You can't feel it in the hot liquid anymore. And I mean, you couldn't see it anyways because it's black coffee, but you can't see it even if it was see-through because it dissolved. But then when you sip your coffee, it tastes better because it tastes sweeter. You got a little bit of sugar in there. The sugar is still there, which is why your coffee tastes sweeter now, but it's just changed shape. It's physically changed from big sugar crystals into microscopic sugar crystals. So physical changes are all about starting and ending with the same matter, with the same substance. It just changes shape a little bit. It doesn't look the exact same as it did when it started, but it has not changed into something new or something different. It's still the same stuff, just in a different outfit. All right, so those are our first two things that I wanted to talk about. Does anybody have any questions about physical properties or physical changes? Anything that I've got over so far that you want me to clear up a little bit?
No, sir.
See if there's anyone else. Doesn't look like it. All righty. So physical properties, things that we can see or observe or describe about our matter. Physical changes when we change the shape of something, but it's still the same material. Now, what about if we don't end up with the same thing that we started with? What happens if we create some new chemicals, some new compounds, some new matter that we didn't have there before? We start and we end with different stuff. If that's the case, then we no longer have a physical change on our hands. Instead, we have a chemical change. So a chemical change, also sometimes referred to as a chemical reaction, is a change in the identity of a substance. So we're changing what our substance is. We're taking some set of starting material, some starting substance, and it's being changed into something new, something different, something that was not there before. So we have different properties. Right? Our different substances aren't going to have the exact same properties. They're probably going to differ a lot in terms of what we can observe about them. So there are lots of different signs that a chemical change could happen. You could have a color change. And by color change, I don't mean that like you add the grape Kool-Aid flavor into a pitcher of water and it turns purple. That's not the kind of color change. Instead, I'm talking about if you've ever been to like a public pool or something and you see the people doing like the water tests, they'll gather up some water and then they put these little droplets into it and it'll cause the water in their tubes to change color. It's clear water and it's clear drops, but a new color is formed. And it's telling them about like the chlorine level or the salt level or the pH of the water. And so that new color forms because there's a color change when the testing drops hit the water. They interact in some way and create a new substance that has a different color than what was there before. You could also have a new gas or a new solid be created as a result of your chemical change. So formation of a gas happens a lot. It's why you see, like if you ever have done the classic experiment where you mix vinegar and baking soda together, all of a sudden they start giving off a whole bunch of like bubbles and they start overflowing and it creates this whole reaction. That's because one of the things that they made was a gas that was not there before. And so that gas bubbles to the top and wants to come out and go up into the air. You also, in certain chemical changes, can see light or heat being produced. So like fireflies, for example, that fly around in the summer and have the little butts that light up. That happens because of a chemical change inside of their abdomen where they take a certain protein and cut it in a certain way. And when they do that, light is released because now they've created new substances, new chemicals out of what was there before. And so when they change from that one set of chemicals to another one, it releases light. You can also have changes that release heat. So you guys probably don't have these as much down here. But like I mentioned earlier in the year, I lived in Ohio for a couple years. And while I was there, I fell in love with the little hand warmer and foot warmers. And what they are these little packets that look kind of like the like silicone gel packets that you get in like new shoes that are like, don't eat these, throw away immediately. These are like bigger versions of that, But before you're getting ready to go outside, when it's like, I don't know, 9 degrees outside, before you put your gloves on, you take the packet, crumple it up a little bit, and then slide it under your glove. When you crumple it, it brings the two chemicals in there, the two matters in there together. And when they do, they start to go through a chemical change. So they start to produce a different substance in there. Part of that chemical change causes them to give off heat. So it's a nice way to keep your fingers and or toes warm when it's ridiculously cold outside, because you have this little packet that's generating its own heat due to a chemical change happening inside, one substance being turned into something else. So some really common chemical changes include things like burning and rusting. So if you think about it, burning, we're giving off light and heat. So you got firelight and you got heat from the fire, already suggesting you have a chemical change going on. But also think about what happens when you burn a wood log. You get smoke that goes up into the air. So that's like a type of gas that's being produced. And then when it's all burned out, you have all those ashes that are left over in the bottom of your fire pit. The smoke and the ashes are different substances than the wooden log that you burned. So that's how you know that a chemical change has occurred. You started with this big wooden log, but now it's been changed into smoke that floated up in the air and ash that was left over on the ground. So you started off with one substance, but you ended up with totally different substances. That means you had a chemical change. Rust is also the result of a chemical change. So the scientific name for rust is iron oxide. And it happens when you have the iron metal, like in these chains here, that sits out and it gets exposed to air and water over a long period of time. So when the iron and the oxygen and the air and water interact with each other, they go through a chemical change and form a new substance on the top of the iron called iron oxide. So whereas normal metal iron is silver and shiny and smooth and really hard and tough, iron oxide, aka rust, has a lot of different properties, right? It's brown, it's super bumpy and crutchy, it'll flake off the top of the iron. And so very different set of properties from the original iron itself. So rusting is the result of a chemical change from iron and water and air to iron oxide, aka rust. Another good example is if you ever have taken like old school Alka-Seltzer medicine, if you had like some heartburn or some indigestion type stuff, you know the classic reaction is you drop the tablet into your little cup of water and then it immediately starts fizzing. All of these bubbles get produced like crazy. The reason why that happens is because all these bubbles are a new gas that is being formed due to the reaction between the water and the tablet. So the tablet is coated in not just the medicine, but also this chemical that'll cause it to react with the water. So the water and the tablet react together and it produces lots and lots and lots of gas. Again, this gas was not here before. This is a new substance being produced by the interaction between the water and the tablet. And so we have a chemical change on our hand. The water and the tablet are being chemically changed into this gas that is then bubbling and fizzing up to the top of our cup. Estrella, you are right on the money with that one. So same basic principle is happening when you see those Mentos and Diet Coke things that were like a really big deal probably about 10 years ago. And it's still really fun to do. But I forget exactly which chemicals it is that interact, but some of the chemicals in the Diet Coke and some of the chemicals that go into making Mentos react with each other when they come into contact, and they produce a new gas in a really high volume really, really quickly. And so the Mentos sinks to the bottom, but then starts producing all of this gas super fast. And so all that gas pushes the Diet Coke up and out of the container in like that big spray, right? So yes, that is exactly because of a chemical change. All that spray is due to a gas that was not there before. It did not exist until the Mentos and the Diet Coke interacted with each other. Great call. That is the exact same idea as what is going on. So yeah, anytime you have some sort of new gas or some sort of new smoke or new compound being produced, that means that you have a chemical change going on. So that's the reason why you don't have gasoline coming out the back of your car's exhaust system, right? You put gasoline in, and then it gets used to make your engine go. But when it gets used, it gets turned into a couple different gases like carbon dioxide and carbon monoxide and water. So that is what comes out the back of your exhaust pipe. As the gasoline goes through your engine and is combusted, it goes through a chemical change and is turned into new chemicals, different gases and liquids that you then get rid of in your exhaust system. So anytime you have any sort of substances changing or producing a new substance, that is when you have a chemical change on your hands. So how can we describe what types of chemical changes that substances will go to? How can we describe whether or not something will catch on fire, or whether or not something will interact with the moisture in the air, or will interact if it's placed in water? In order to do that, we use things called chemical properties. So a chemical property is different than a physical property, because while a physical property describes a observation or a description or a measurement of a substance, a chemical property describes its ability to go through those chemical changes. So like, for example, how flammable an object is one of its chemical properties. So like the wood that we saw in the fire example earlier, or stuff like gasoline or propane or ethanol even, is very flammable. So ethanol, the reason why, if you've ever seen a bartender make like a flaming shot at a bar, the reason why they're able to do that is that ethanol, the type of alcohol that we drink, is a flammable material. And when you get it present in high enough concentrations, like in something like Bacardi 151 or Everclear, you're actually able to ignite the ethanol in that substance. So ethanol, propane, gasoline, wood are all very flammable materials. So one of their chemical properties would be that they have a high flammability. Whereas things like plastic or metal or rubber are not as flammable, right? It's a lot harder to light those types of things on fire. So some of their chemical properties would be that they have a low flammability. They don't light on fire very easily. And then also reactivity, which is a way to describe how likely a substance is to go through a chemical reaction with another substance. So like iron, for example, is reactive to air and to water. Alka-Seltzer tablets are reactive with water. Really certain pure metals like sodium, which is a metal, and potassium, which is a metal, and their pure forms, they are extremely explosively reactive with water. Like even letting them be introduced to the air is a bad idea because they will react violently and explode if they're exposed to water. Like I mentioned earlier, baking soda is very reactive with vinegar. So if you mix those together, you'll get a very sudden, very violent reaction. So how likely a chemical...
Excuse me.
Yeah, go for it.
Is that what they do on the science experiments? Like, I don't know if y'all remember back in middle school where they do the volcano?
Yep, 100%. Same basic idea. And again, it's the same sort of basic principle as like the Alka-Seltzer and water or the Mentos and Coke, is that when those two substances combine, they very quickly produce a new substance, which is a gas. Its natural state is a gas. And so that gas then bubbles up very quickly through all of the vinegar and baking soda that have been combined. It bubbles up very quickly. And so, yeah, people use it in like the old school volcano experiments because then it makes this nice kind of like mini fountain that kind of comes up and then spills over the side of the volcano. And it's all due to producing a very large amount of gas in a very small area in a short amount of time. But yes, those two chemicals would be said to be reactive with each other. That would be one of their chemical properties. On the other side, there are certain chemicals which are super non-reactive to other substances. So things like the gas that they use in like those cool neon signs in front of like stores and like in Vegas and stuff like that. So like neon or argon or xenon, they are all super, super non-reactive. One of their chemical properties is that they really, really do not react with other substances that are in their area. They're set up in a way, their chemicals are aligned in a way to where they're perfectly happy doing their own thing and not reacting at all with any other molecules or chemicals that are around. So certain chemicals, super reactive, super even explosively reactive. Other chemicals, very, very low reactivity. They don't want to react or do any sort of changing with any chemicals around them. So that's what chemical properties about a substance tell us. They tell us if it can go through a certain type of chemical change. How likely is it to react with itself or with other chemicals if placed in certain situations? How likely is it to catch on fire if it's heated up in a certain way? All of these are chemical properties of our substances. All right, got some great questions and some great points so far. Anybody have any more questions or anything that they want to ask about chemical properties or chemical changes, turning one set of substances into something new?
No, sir.
I kind of have a quick question.
Yeah.
I'm just curious if it's chemical property or like chemical change. So on my kids, they had like a science project. This was like years ago, but they used soda, which was like one was a Sprite and one was a Coke, in order to blow up balloons. So what is that? They just shook bottles, and I mean the balloons blew up. I know it's gas, so is that chemical change?
So I believe in that case, it would actually be a physical change. And here's why. The reason is because that gas was already there. It was inside of the bottles, right? So when Coke or when Pepsi or whoever make their sodas, they combine all of the sugar and the acids and whatever other sweeteners and stuff, flavors that they want to put in there. And then before they seal the top on their bottle or their can, they inject a whole bunch of carbon dioxide gas in there. And that's what gives it all of the bubblies. So that's what makes it taste so nice and bubbly. And that's what gives it the when you open it, is some of that carbon dioxide gas releasing. But that gas isn't being produced by a chemical reaction. It was just in there, kind of mixed in with all of the other ingredients, essentially. And so when you pop the top, it releases some of that carbon dioxide gas. And when you shake up the bottles, it causes more and more of the carbon dioxide to be released. And so that is what makes it a physical change, is because the gas is coming out of the top of the soda bottle. And then, like in the experiment you were talking about, it is going into the balloon. But the gas isn't being created or produced by some process. It was already in there. You're just basically helping shake it all loose. All right. No worries. That was a great question. So yeah. So again, chemical change is when you do create the gas on its own, but a physical change is just when you move something around or change the shape of something. So in that case, the gas wasn't produced as a new product. It was in there already. You just moved it from the inside of the can into the balloon or into the outside environment. Great question. Anybody else have any chemical versus physical property or changes types of questions? All righty. So the homework for this one is a little bit long, but it's very easy to answer questions and should be pretty straightforward. It kind of comes in 3 different parts. So for the first part up here, I want you to picture like a piece of wood in your head, like a branch from a tree or a log that you see laying on the ground. And I want you to list out 3 physical properties that you could observe about that wood and 1 chemical property that you could guess that wood would have. And then, so that's the first part. Second part is, I think it's like 10 questions where I give you a whole bunch of different properties of materials. And I want you to tell me, is this a chemical property or is it a physical property? So you literally just have to go through and click on chemical versus physical property for each one. So things like what temperature that iron melts at, or the fact that you can turn copper and twist it out into a wire, or that you can light ethanol on fire, or that diamonds are an extremely hard type of rock. For all these, I want you to tell me, is this a chemical property or is it a physical property? So we're going to do that for 10 questions. And then the third part is a little bit longer, but it's basically the exact same setup. Except instead of answering questions about properties, you're answering questions about chemical or physical changes. So it has a little bit of an introduction type part. And then each one of these you'll classify as a chemical or a physical change. So you melt, then evaporate some ice. You tear a piece of paper into a whole bunch of smaller pieces. You combust some gasoline inside the engine of a car. You take a whole bunch of red and blue marbles and sort them out based on color. You heat up some baking soda and it turns into its base chemicals. You take some sodium metal and you cut it down the middle and turn it into two pieces. You run some electricity through a long wire. For all of these situations, I want you to tell me, does this best describe a type of physical change or a type of chemical change? Again, I know it's a little bit long, but for each one, you literally just have to put in chemical, chemical, physical, chemical, physical, physical, chemical, etc. So hopefully it should not take anybody too long. All right, does anybody have any other questions about our different types of chemical or physical changes or properties, or the assignment that was posted for today?
I had a question. So, will the notes, like for both, like all of the notes that we have, would we be using that for this assignment, or just the matter changes, like the matter classification of matter, those notes?
So for this assignment, it's going to be pretty much just based off of these notes right here.
Okay. Thank you.
Mm-hmm. That's usually how I try to get the assignments to kind of line up. And so it might be a pattern that you see as we kind of go forward, where usually the Monday assignment will be like some sort of simple question that's kind of a review from the last week. And then the Tuesday and Wednesday assignment will be based around the Tuesday notes. And then the Thursday assignment will be based around the Thursday notes. And that's pretty consistent, I think, for most of the weeks that we're going to go through here.
Okay, thank you for clearing that up.
Yep, no problem. Any other final notes or homework questions?
Are we gonna end up having like a project at the end of the term?
So unfortunately, with all of the like online stuff, we don't really do a ton of projects in this class. I haven't figured out any that work really well for the kind of virtual world. But there is a open note midterm and open note final exam. So the midterm happens at about the halfway point, so a couple weeks from now. And then the final exam happens at the very end of the term. All right, good questions.